Hello everyone, this is the fifth chapter, Measure of Dispersion. Okay, I'm glad to inform all of you that this is the fifth chapter, and first to fourth chapters response on YouTube was very good, and all credit goes to my dear student. Thanks for watching and keep watching, and comment me if you have any doubt. Okay, after the fifth and sixth chapter, syllabus will over. After the completing of syllabus, we will start the QPs. QPs of SPPU, question papers of SPPU, Savitribai Phule Pune University. Okay, Pune University question paper. We will start the question papers. Okay, and discuss about the paper pattern after the completion of fifth and sixth chapter. We will start the QPs of SPPU and paper pattern. Okay, so keep watching and like, share and subscribe. Thank you. Now we will start the fifth chapter, measure of dispersion. Why we study the dispersions? Okay, see, this is the data marks of student A B C in a 5 subject. See, student A B C. Okay, 5 subjects, marks in a 5 subject and arithmetic mean of that marks. Okay, all of you know this. What is this arithmetic mean? Okay, see here, observe the data, how data is scattered and arithmetic mean same. Okay, data is scattered but arithmetic mean is same. Okay, how it is possible? Okay, we notice that average marks of all the students are the same. See, arithmetic means this is the average. We can see that it is average marks of all students is same. Okay, see, but they differ in a variation. See the variations, how the data is scattered. Okay, see, from this data we can observe that A is more consistent than B is more consistent than C. Okay, so further study and analysis, it become essential to measure the extent of variation observations. Okay, and observations are scattered. Okay, or we can say disperse. Okay, from the central value. Observations are scattered or dispersed from the central value. This is the central value. Okay, but observations are scattered from the central values. See, observe that 0 and 15. See, 50 and 15. How much difference is there? But still arithmetic mean is 50. So that this variation is called as dispersion. Okay, this variation, we can see that this variation is called as the dispersion. In other words, we can say the degree to which the numerical data tends to spread on average value, it's called as the dispersion of the data. I write the definition here. Okay, this is my definition of measure of dispersion. What is the definition here? The degree to which the numerical data tends to means approach to, okay, spread on the average value, it's called dispersion of the data. Okay, definition asked in exam for 2 marks. Okay, take a screenshot. Next is the range. First topic is a range and coefficient of range. Very simple topic. Okay, see, sometimes in a first questions they ask find mean, median, mode and range for the only observation, for the only observations. Okay, sometime ask in exam. Okay, now range, it is the simplest measure and suitable if the extent of variation is small. If the extent of variation is small. So what is the range? See, range, it is very simple. Range is the, if L is the largest observation, L is largest observation, from the data, okay, and S is the smallest observation, smallest observation. Then the range is the difference between L and S. Then range is the difference between L and S. Okay, this is the definition of range. Okay, suppose for example 2, 3, 4, 9 and 0. These are observations. Okay, what we have to find here? Range. What is the largest observation here? 9. Smallest is 4. Okay, sorry, smallest is 0. So range is 9. Okay, we can take here 1. So 9 minus 1 is 8. So range is 8. Okay, this is the definition of range. What is the definition? If L is the largest observation and S is the smallest observation, then the range is the difference between L minus S. Okay, understood? And the next relative measure is coefficient of range, and formula for coefficient of range is L minus S upon L plus S. L is the largest observation and S is the smallest observation. Here difference, here addition. Okay, again I am making here a rectangle. So understood that it is a very important formula. See, this is the example. Very simple example. Okay, compute the range and coefficient of range. Okay, I already told you that sometimes in an exam they ask for compute mid, median, mode and range for this data. So all of you know how to find the mid, median, mode for this data. Okay, see, smallest observation, which is the smallest observation here, is 14. Largest observation, which is the largest observation here, it is 106. Now find the range. It is L minus S equal to 106 minus 14 equal to 92. Find coefficient of range. Equal to L minus S upon L plus S. L minus S means it is 92, already calculated. L plus S means 106 plus 14. So it is 92 upon 120. Okay, so it is 0.7667. This is the range and coefficient of range. Okay, understood? You can take screenshot here. Next topic is quartile deviation. Okay, see, the range uses only two extreme value. We studied the range. Okay, and range uses the only two extreme value, large value and small value. Okay, if I made any change in between the observations, see, observations are 0, 2, 5, 9, 1. Okay, so L is 9 and S is 0. Okay, in between the observation I made this change 3. Okay, so it is not going to affect the range. It is not going to affect the range. Answer is same. Answer is 9. Okay, this is the main drawback of this range. This is the main drawback. So in many situations, extreme atoms are widely separated, okay, from the remaining atoms. See here, 5, 3 and 9. So difference so many gaps is there, means number gap is there. Okay, 9 minus 3, so gap is there. Okay, 1 and 9, so gap is there. Okay, so observations are separated from the remaining atoms. In this situation, range will overestimated the dispersion. Okay, range will overestimated the dispersion, so range fails to give the true picture. Okay, true answer. Okay, so this is the drawback. So for overcome this drawback, they introduce quartile deviation. Okay, in order to overcome this drawback, the range of middle 50% atom is computed. Means in order to overcome this drawback, we will see the quartile deviation here. Okay, see. See this diagram. Okay, this is the total observation. Small value is here, large value is here. All of you know what is S, what is L. Okay, I put Q1 here, Q3 here. Okay, because of Q1 and Q2, data is distributed into three parts: 1, 2, 3. Okay, 25% here, 25% here. Obviously, this is the 50%. If we can say this is 100% data, then this is 25, 25 here. So middle is 50%. So what is the definition of quartiles? See, we have seen the median. Okay, we already seen the median. So median is divide the total number of observation into two parts. Yes. Similarly, in order to make the four equal parts of the data, we use the quartiles. Okay, median divides into two parts. All of you know this. Okay, and the quartile divides into the four equal parts. Okay, for making a 10 equal parts, we use the deciles. Okay, for making 100 equal parts, we use the percentile. Okay, see what is the definition of the quartile. The observation Q1, Q2, Q3, which divides the total number of observation into the four equal parts, are called as the quartiles. We will see it by graphically using the frequency curve. See, this is the total data. Okay, frequency curve. All of you know curve is drawn by smooth hand. We already studied in the data condensation. So this is my curve. Okay, this is x-axis, this is y-axis, this is my data. Okay, and I put q1, q2, q3, means I just divide the data into the four equal parts: 1, 2, 3, 4. Okay, see, ultimately this is the 25%, this is the 25%, 25%, this is 25%. Okay, understood? So these are quartiles. We can say that q1, q2, q3. And what is the q2? Q2 is median. We already studied the median. See, median divides the data into two equal parts. Okay, see, this is the 50% and this is the 50%. We already studied the median, so q2 is median. Formula for q2 is same. Okay, understood? See, nobody will ask in the exam that how the frequency curve is drawn for quartiles q1, q2, q3. If you don't understand, just watch and skip this portion and concentrate on the formulas and questions. Okay, just learn the formulas and examples. Don't take tension about this graph and previous graph and quartiles and all. Okay, just learn the formula and example. Okay, don't worry, we will see the example. See, one by one we will see the formulas. First, q1, we called it as a first quartile. Okay, See, L plus n by 4 minus CF upon F into H. Okay, it is same, it is similar to median. Okay, formula is similar to median, not exactly similar, but process and all steps all are same. Okay, so I made a box, so it is important. So this formula is used for finding the first quartile Q1 for frequency distribution. If data is in the frequency distribution table, means frequency classes are given, then we use the first quartile Q1 equal to L plus n by 4 minus CF upon F into H. This is the first quartile. Now, second name, this is the Q1. Means what? First quartile. Okay. Formula n, small n plus 1 divided by 4 observation. See, this is used for only observations are given. See the difference. This is used for only observations are given. Okay. Individual observations are given. And this is used for frequency distribution table. See, capital N is related to frequency. Total of frequency is the capital N. Here small n means what? Number of observations. So this formula is for individual observation and this formula is for the frequency distribution. This is about the first quartile. Okay. You can take the screenshot. See, next, second quartile. Okay. Second quartile means Q2. Q2 means median. Medians divides the data into two equal parts. Okay. So we already studied the formula. Formula is same here. Okay. Median equal to L plus n by 2 minus CF upon F into H. Okay. Same formula we studied in the measure of central tendency. Okay, this is the same formula. This formula is used when frequency distribution table is given. Okay, see the Q2 median n plus 1 divided by 2th observation. This formula is used when only observations, individual observations are given. Okay, small n denotes number of observation, capital N denotes the total of frequency. Okay, all of you know this. This is the lower limit of median class. This is the width of the median class. CF is the cumulative frequency. N by 2 is the n is the total of frequency. Okay, understood? Now take a screenshot. See, third formula. Okay, third quartile Q3. L plus 3n by 4 minus CF upon F into H. This is for frequency distribution. And Q3, this is for the only observation. Individual observations are given. Okay, 3 into n plus 1 divided by 4 observation. Okay, this is for only observation. This is for frequency distribution table. Okay, understood the formulas? See the example. Find the quartiles. Okay, see what they given only observations. Okay, so first arrange these observations in ascending or descending order. Okay, 5, 6, 7, 9, 11, then 15, then 18, then 20, then 26, 30, 35, 40, 45, 49, and last is 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Means small n is 15 here. Okay. Total number of observations. Okay. Total number of observations, small n. Okay, what we have to find here? Quartiles Q1, Q2, Q3 for the individual observations. Okay, first quartile. I write here Q1 directly. Q1 equal to first quartile Q1 equal to, what is the formula? Formula is n plus 1 divided by 4th observation. Okay, it is very simple. N plus 1 means what? 15 plus 1 divided by 4. So it is 16 upon 4. It is fourth observation. Fourth observation is the Q1. Fourth observation. 1, 2, 3, 4 means 9. So it is ninth observation is the Q1. Okay. Now second quartile. Q2. What is the formula? It is same as median. N plus 1 upon 2th observation is the formula. Okay. I write here observation shortcut. So n plus 1. What is n plus 1? 15 plus 1 divided by 2. So 16. 16 upon 8. It is 8. 16 upon 2, na? 2. So it is 8th observation. 8th observation. 1, 2, 3, 4, 5, 6, 7, 8. Means this observation is the median. Okay. This observation is the median. Means 20 is the Q2. Now, Q3. What is the formula for Q3? Q3 is 3 n plus 1 divided by 4 observation. Okay. This is not the Q1, Q2. This is not Q1. Fourth number of observation is the Q1. Eighth number of observation is Q2. Okay, understood? Okay. Now, it is 3 into 15 plus 1 divided by 4. So, it is 16. 48 divided by 4. So, it is 12th observation is the Q3. So, 12th observation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, 40 is the Q3. Understood? So, Q1 is 9, Q2 is 20 and Q3 is 40. This is the quartiles. Okay, understood? If any doubt, please comment. Now we will see the example of frequency distribution. Okay, for finding the Q1, Q2, Q3 for the frequency distribution, we have to follow the steps of median. Okay, if you understood the median, then you can easily find the Q1, Q2, Q3 for frequency distribution. Okay, note, already told you median is Q2. Okay, see Q1, Q2, minimum value less than Q1, Q2, Q3 and maximum value. Okay, so remember this. Okay, see in the earliest example 9. Okay, then I think it is 20, then 40. See. Okay, understood? If any doubt, please comment.